Hello, everyone. Thank you so much for attending today's event. I am Mike McCumber. I am a marketing manager here at DigiFabster. I'm also joined by our application engineer, Alistair McGrath. He's going to cover today's topic. So we're going to dig into how to easily incorporate your shop's pricing structure into a quoting automation system like DigiFabster. So this gives you the ability to not use standard pricing, but use your own incorporate your own knowledge and your own pricing into your setup. So it should be a very interesting topic. You do have the ability to ask questions. So what we're going to do is do that via the questions or chat functionality. You should see that in the lower right-hand corner of the conference tool. So feel free to type in your questions there. We will read them out loud so everyone can hear the question and the answer, because oftentimes people do have the same questions but don't ask it. So we'll do that. So I think with that, I am going to hand it over to Alistair for today's presentation.
Thank you. So essentially, just to preface, we'll be going over kind of the theory of the different machine and material setups you can do in DigiFabster. And then I'll do an actual example of a machine setup. That way I can go over all the different parameters as well as our price tweaking tool. And after that, I'll talk a bit about our professional onboarding service, and we'll conclude with a Q&A session. So while many shops use complicated spreadsheets to come up with their pricing, DigiFabster was designed to be easier and more user-friendly to configure, while still maintaining robust functionality. So under the settings for each of your machines and materials in the backend, you'll find a list of parameters that you can choose to set different prices for. This includes common pricing aspects used by most shops, such as hourly rates, lead time rates, material costs, overhead costs, additional for services, etc. Essentially what you'd need in order to replicate your pricing inside DigiFabster. So from those parameters, your shop can pick and choose which data is actually used to create those pricing algorithms for those different uploaded parts and models. And essentially, it'll just tally up all those different results that you've put in and then calculate it against that machine that you set up in the backend. So we have a very large range of flexibility with those pricing models, and we can account for a lot of different scenarios. For example, depending on how many machines a particular shop manages, a shop could create a specific machine in the backend with precise metrics that represents an actual machine that they have, or they could choose to set up a single generic machine that represents a large number of CNCs with similar size ranges and capabilities, for example. Another common route that a lot of shops choose to go is to set up bin pricing. So in the system, since it's less cost-effective to price both small and large parts the same way, you can create several different size ranges with different pricing parameters on each range. That way, different sized parts can be directed towards those specific bins and then priced accordingly. And that's one of the methods that a lot of our shops use to get very precise pricing. Another useful feature is our ability to set manual review thresholds based on either order value or part quantity. So with the machine-specific threshold on part quantity, you could use this to avoid receiving a very large order that might overbook your capacity, for example. And I'll show what that'll look like in the next step as I show the actual backend of the software. And then with the other example, if you had the price-based threshold, you could hold orders over a certain value for manual review. That way you can ensure high-touch sales for larger orders. We can also configure several different kinds of discounts to automatically apply on top of all these other parameters that you can set. So for example, you could set a promotional discount for special events, client discounts for select repeat customers, order discounts if it's over a specified price threshold, and then you could also set batch discounts. This way it can apply on orders that have repeated parts. Next, let's move into the actual backend of DigiFabster software, where I can go over the setup of a generic CNC mill. And then afterwards, I'll talk a bit about the price tweaking tool. So here in the backend of the software, I'll just start by creating a new machine. From there, I can choose my technology from this dropdown, and for now, I'll select this multi-axis mill to set up. Here we have a list of common industry standard machines, but if I were adding a generic machine, I could do so easily just by adding its own custom one here. With that, I'll fill in the travel size. And for now, I'll just set 1,000 millimeters. And then in addition, I'll set up this minimum allowed part size. So as I mentioned before, if I were to set a value of, let's say, 500 here with this X value, we could force certain size parts over 500 millimeters to a larger machine if I were to set up multiples. For now though, I'll just leave these all at 1, so that this way, if a tiny part were to come in, or if a part were uploaded in the wrong scale, we could recognize that. Moving down to our machine specs, I'll set my machine speed at 1,000 cubic centimeters per hour. And this is just the baseline speed. We'll add other modifications in to account for other changes based on the material as well as the complexity. Next, I can set a price per hour for using this machine. And I can also apply a per part fee. And this would be applied for every single part. So if there were 10 repeat models, it would apply this 10 times. And some shops use this to reflect the cost of deburring those parts, for example. Or alternatively, they could just set a higher startup cost later on. And then here we have our manual review threshold. So as I mentioned previously, if I were to set this here and the order were to come in with 51 parts, it would hold that for manual review. That way you could approve it before it actually goes into your production line. Moving down to tolerances, we can add multiple different tolerance options for our users to choose from. So besides this baseline tolerance, I'll also add this higher tolerance option and include it at an additional margin. And this will only affect the quoted price and not the cycle time. Moving down to features, if I were to have features such as holes, I could activate it here, select the feature type as cuboid, and say it costs $5 per hole as well as $5 to set up. And of course, if you were to offer multiple options with this as well, so if you had through holes as well as threaded holes of a specific pitch, you could add that specific pitch here under the name, and then choose to have it priced either the same way or differently. And I'll say it costs $10 to set up this one, since you'd have to change that tool head. And then moving down to lead times, we can add multiple different time scales for our customers to choose from. So here we have this baseline 10-day lead time, but if I wanted to offer an expedited option, I could have a 2-day turnaround time with an additional 40% margin, which is just an easy way to upsell customers who might need their parts very quickly. Saving the machine, we can move on to the creation of our material. And here we have this list of common machining metals, but again, if you wanted to add your own material, such as a copper or a composite or a plastic, you could add your own material the same way we added our own machine. For now though, I'll choose aluminum 7075, and then I'll change the display name that actually gets shown to users. Next, I could add notes as well as material spec sheets, just to give the end user the best idea of what material it is they're choosing. Below that, we can apply a startup cost, and we can set this to be triggered from multiple different metrics for a shop. So we could have this go off for every unique model, every unique material, every unique execution, or every unique priority. Below that, we can add a flat programming cost associated with every unique model. So this could reflect the cost of nesting your models, as well as just setting up that actual machine. And then below that, we can add our expected production time in days, just to give the end user an idea of how long it might take to turn around their part. Moving on to material specs, with our minimum wall thickness, we can help to recognize models that might be too fragile to machine. So if a model were to come in with walls less than this 1 millimeter, it'll highlight those in red just to show those different fragile areas. Next, with the machinability, this is how we represent how efficiently something can be machined. And it's based on ANSI standard guidelines for metals, and it was automatically filled in when I chose that aluminum template. But you can change this if you know your exact capabilities. So for example, with this at 120%, that essentially means that it can be machined 20% faster than the baseline machine speed we set previously. Below that, we can account for work hardening by changing this work hardening exponent. And then we can also add extra material to the bounding box, and that would just become the starting machining volume. So some shops add this in to account for scrap material for imperfect nesting, essentially just to account for that additional space between parts. Moving on, typically there's also a price set per square centimeter of surface. And essentially this is here so that if you wanted to do an additional finishing pass, you could account for that price. Then moving down to the material costs, depending on what materials you use, you could set up multiple different bar stocks, round stocks, And the simplest option would be to simply price per kilogram of material. So here I'll put the density of aluminum, and I'll say it costs $2 per kilogram. Finally, moving to post-production, if you offer any additional services, you could choose from these generic ones here. So for now, I'll choose grinding, and then you can choose to have its price be calculated per model surface area, model volume, model bounding box, or just a flat per part fee. So with grinding, I'll say it costs 10 cents per square centimeter, has a minimum price of $5, and adds 1 extra production day. And of course, you could add your own additional services. So if you offered anodizing or heat treatment, you could add your own custom post-production type here, and that'll just appear as an option for users to choose from. Saving the material, I'll jump back into the machine once more to go over complexity bracketing. So whenever parts are uploaded to DigiFabster, we automatically analyze the parts, and we break them up into different bins based on their complexity, ranging from very simple to highly complex. And here with this complexity bracketing, we can adjust the cycle times of these different bins. And this is flexible so that you can match it to your shop's real-world data. So for example, if a shop were very good at machining highly complex parts, then we could decrease the cycle time for these highly complex ones. And in contrast, if your shop was very good at machining simple parts, you could have a lower cycle time for those simple ones. And then once you're done adjusting all these settings, you can apply it, save the machine, and just like that, you have your machine baseline setup. Next, I'd like to move to talk about the price tweaking tool. So this is a very useful feature we have so that this way you can actually tune in your different prices. So here you'll select the different machine and material, and then you can choose to add your own model or just choose from one of these baseline ones here. And essentially, this would just give a breakdown of all those different parameters that we previously set. So here I can see the estimate for the time it takes, as well as the estimated price that comes out of that, as well as all these different estimates for all our different parameters. And if I decide that this price per kilogram should be changed to 1, I can see that new price. And then once I'm satisfied with this tweaking, I can accept these settings on my machine. And just like that, I've tweaked this material here. So just to clarify, this essentially just gives that price breakdown for a specific part on your machines and materials. That way you can tune your pricing more effectively. So some shops may find all this algorithm and setup and tweaking a bit daunting. Luckily, we also offer a professional onboarding service where one of our application engineers can assist with the setup. And essentially, what's required for that is we'll take 10 to 12 of your different parts with their historical pricing, and we'll use them to come up with the different parameters necessary to replicate that pricing in DigiFabster. It especially helps if the parts represent a good range of sizes that you work with, as well as different prices. That way the algorithm can be more rounded. And that concludes the different things that I had to go over regarding these different pricing setups. But at this point, if you have any questions, please feel free to put them in the chat window.
All right. Actually, we do have looks like a couple questions here. Can I set up tiered pricing for orders with hundreds of repeated parts?
Yes. So as I mentioned with our different discounts that we can apply, if you wanted to set up a different discount on 50 parts versus 100 parts, you could set it up that way. So if a user were to upload all those parts and specify those quantities, we can automatically figure out which bracket they should fit into.
Excellent. Looks like we do have another one. How long does it take to fine tune the back-end pricing accurately?
So typically most shops, if they devote the time, they're able to get the pricing into an acceptable range within about 2 weeks, especially if they have a good idea of those different metrics that they use for pricing. That way they can reference them while going through this setup process.
Great. All right. If you have any more questions, please feel free to enter them in the chat. We'll give it a few more seconds here, Alistair, and if not, we can wrap things up.
Sounds good.
All right. We will have this event available, recording of this event available rather. We'll email you the link to that So if any other questions do pop up, feel free to reach out to us and we could get those answered for you. Just a reminder, we do these on a monthly basis, so stay tuned for on our social media channels, or of course we always send email invites. But yeah, any additional questions, feel free to reach out to us. Thank you so much for attending today's event. And if we don't chat prior, have a great holiday season and a new year.